probability, let's discuss the question related to without replacement. This is the most common question in past papers. I'll give you the data. In a basket, okay, inside a basket that was a closed basket, only one hole to enter your hand. That is the only thing appearing here. Inside that we have some cards. We have some cards. Those are equal in size. We have 6 cards. In each card, the numbers were noted from 1, 2, 3, 4, 5, and 6. These are the cards having from 1 to 6 numbers. All are equal in size, so there is no any partiality between the cards. When you enter your hand inside the box, you can select a random card. We don't know which one we are going to select. So, without replacement means, first of all, you are putting your hand inside the box and taking a card, and you are going to keep the card with you. For an example, first of all, you are selecting number 4 card and keeping the card inside your pocket. And again, you are going to input your hand inside it and selecting another card. Now, there is no any number 4 card still in that box because you have taken that one out. No, you taken it out and keep it with you. So when you are entering your hand inside the box again, you will not find any number 4 cards. So you can have only 5 cards from 1, 2, 3, 5, and 6. This is the questions are called as without replacement. First, the probability of all the cards is same. Next, you are going to take a card and keep it with you. That means you cannot take the same card again from the box because there is no any other 4 inside the box. No, only 1 4 are there. You have taken that out and keep it with you. There is no any more 4 number inside the box. In these cases, we will draw the sample space. This is our first try. First try should be denoted in the x-axis and in the horizontal axis, second try. We don't know whether we are selected number 4 or 1 or 5 or 6. From amongst these 6, we have selected only one, but we don't know which one we have selected. For an example only, I used number 4. So in the horizontal axis, you should mark the numbers from 1, 2, 3, 4, 5, 6. In the vertical axis also 1, 2, 3, 4, 5, 6. Here the key thing is while you are marking your sample space, that is the important one. Let's think about this event. There are 36 events. We will check if there is any possibility to have an event like this or not. Think about it. In first try, you have selected number 1 and keep it with you. So you cannot select number 1 again from the box. When you consider about this event, you have selected number 1 from your first try and keep it with you. So when you are going to select the number again from the box, there is no any number 1 furthermore. So you cannot select number 1 again. So there is no any event like this one. You cannot select same card twice. So this event does not exist in without replacements. Think about it. First you have taken number 1 out and in second try you are taking number 2 out. There is a possibility because both are different numbers. No? You are selected number 1. Again you are selected number 3. Yes, there is a possibility you have an event like this. This is also a possible one. Possible. This is also a possible event. First try you have selected number 1. Keep it with you. In your second try you might select number 6. There is a possibility. Next, check with the next column. First, you have selected number 2. So, there is no any 2 in the box. In second try, you have selected number 1. Yeah, there is a possibility. In each one, you should think from the beginning. In first try, you have selected number 2. In second try also, you cannot select number 2 again because there is only one 2. You have taken it out from the first try. So, there is no any 2 furthermore. So, there is no any possibility to have this event again 2 2. But here first try 2, second try number 3. That's a possibility to have an event like this 2 4. 2, 5, 2, 6. These are different numbers, so we can select them. There is a possibility. 3, 1, first try 3, keep it with you. Second try, you can select number 1. First try number 3, in second try, you can select number 2. Think about it. First try, you are selecting number 3, keep it with you. In second try, you cannot select number 3 again. So in here, don't indicate the cross. The crosses means the possible events we can have while doing this experiment. So there is no any possibility to have number 3 twice. So you no need to put the cross at there. And likewise, when you check with other ones, only non-possible one is 4 and 4. You cannot select same number twice. In the fifth column, 5, 1, 5, 2, 5, 3, 5, 4 is possible. 5, 5, that is not a possible one. Then 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. These are the events because this is called as the cross-sectional region. Cross-sectional region. Look at this. You cannot select the same card again and again. Without replacement, you cannot select the same card again and again because there is only one card exists. You have selected that one earlier. You cannot select the same card again. No, that's why the cross-sectional region that remains unmarked. So while you are dealing with the question without replacement, if you marked any crosses in this interaction region, you will not gain any marks. So you should understand there is no any possibility to have such like events. That's why we didn't indicated the crosses. All the crosses are indicating the possible events we can face from this experiment. In with replacement question we've discussed the cross-sectional region. Here also we can put the crosses, but in without replacement questions, no need. You cannot put any crosses here because there is no any event such like that will happen. Yeah, that's why. That's the reason behind this. And the probability, to find the probability process, that is same as the previous ones. We will discuss some questions. In your exams, they will give you this skeleton and ask you to find draw the possible events as crosses. So if you denoted anything in this region, you will not gain any mark. You should understand properly. In first, try an even number. Second, try odd number. So you should select all the possible events. First, try even number means in first try here in all these events we are selecting an odd number. Here and here and here. In first try we are selecting odd numbers, no, so no need to think about these probabilities. We can check with other events. First try even number, second try odd number. First even, second odd. This is a possible one. First or even, second odd. First even in here, second also even number. So we don't want that. This event is possible. First even, second odd. Even. We does not want that one. 4 and 1, this is a possible one. Here this is possible, this is possible. Last, this and this. Total, in total there are how many events? No need to think about them. Totally here we have 30 events. In 30, the events which we need, that is 9. 9 upon 13. If you want, you can simplify to give your answer 3 upon 10. Both are correct. This would be the probability for first event. Next, let's check with the second event. In that, second number is greater than first number. Second number is greater than first number. We will check that. In first try 1, second try 2. 2 is greater than 1. We need this. Yes, 3, 1. In first try 1, second time 3. This is greater than 1. 4 is greater than 1. 5 is greater than 1. 6 is also greater than 1. Let's check with here. 2 and 1. 1 is not greater than 2. And 3 is greater than 2. 4 is greater than 2. 5 is greater than 2. 6 is also greater than 2. These numbers are the first try number. So when you select this event 3, in the second try, in first try 2. Second number should be greater than first one. No? So the condition was satisfied. First time 3, second time 1. We don't want this. Here also First time 3, second time 2. That also less than. 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. And next here, up to here, there is no any possibility to have the ones. Then here, 5 and 6 are greater than number 4. And here we have this. In this, we does not have any relevant probabilities. In total 30, there are 15 events which satisfy the condition. So when you simplify this, you will get the answer 1 upon 2. You can give either this one or this one. Both are correct.